we're going to be going over the last section that we're covering in this class, section 5.3, which is about solving Legendre polynomials. And so the things that we're going to do are we're going to talk over the form of the differential equation that we're solving. We'll solve it using series, we'll do an example, and then we'll touch base on Legendre polynomials, which kind of emerge as part of the solution of this type of differential equation. And I just want to let you all know that sort of the reason we're covering this section is because it's a chance to practice series, which you haven't had a whole lot of chances to practice. And kind of like the special type of differential equation we solve does show up in some important like physical applications, sort of whenever you're thinking about spatial differential equations and spherical coordinates, but the polynomials that we get out of the solution show up in other places too. So it's just kind of a neat thing that might tie into future math classes you take, depending on how far you go. I want to apologize right now that the technology for this set of videos is different from what we've used the rest of the semester. People who were in class on Thursday got to see me battling with this new tablet pen thing in person. Those of you online just got to suffer through the effects of it. I'm going to be doing my best here, but it's the end of the semester. It's a hard time to learn a new thing. So if anything's unclear when you're watching these videos, remember the PDFs are linked on Blackboard for you to look at. So first up, we're just going to talk about the specific ODE that we're solving, and it's going to be what's called Legendre's equation of order n. Man, that's big writing. Okay, so what that's going to look like is something like this. 1 minus x squared y double prime minus 2xy prime plus n times n plus 1 times y. Oh, that one's bad. Times y equal to 0. So that's the specific type of differential equation we'll be solving. So we're going to solve this second order ODE for some number n. And we're going to be using series solutions. So sort of from right here, you could go ahead and like pause the video and plug in a random number n and just see what happens when you try to take a series solution to that. Real quick, I just want to sort of focus in on something that is like true about this equation. So note that we could kind of rewrite it as 0 equal to y double prime minus 2x over 1 minus x squared y prime plus n times n plus 1 over 1 minus x squared y. Sort of that's just algebra dividing through by the thing that's attached to y double prime, something we do a lot in this class. But when we do that, we can see that we run into problems at x equal to plus or minus 1. Okay. So there are problems when x equal to plus or minus 1. So right away, you don't even have to really think much about radius of convergence for this problem for series, because you know that we're never going to be able to reach x plus or minus 1. So we always expand our series around x equal to 0. So, you know, we had that choice to do x minus a to the n in all the series, but what we always do is just x to the n. So the radius of convergence will have to be that our absolute value x is less than 1. Sort of, we're going to start from 0. We can't hit plus or minus 1 because that would cause issues in those dividing by zero type terms. So that's just something we know about this problem without even thinking about series convergence issues. So in the next video, we'll go ahead and work through like the generic solution to this differential equation, but that will take a while, so we'll pause here.